All right, if we keep going, so I'm going to start by replacing tangent with its quotient. So sine theta over cosine theta. And at the same time, I'm going to replace the cosecant with its reciprocal. And I'm going to make my division bar a little thicker here just so I remember where the original one was. So then this will be 1 over sine theta. Now again, we don't want to multiply, or excuse me, we don't want to divide by a fraction. Instead, we're going to multiply by the reciprocal of this. So this is going to be sine theta over cosine theta from the numerator, and then times the reciprocal. So sine theta over 1. Now this time I can't cross reduce, so I'm going to multiply straight across. So I would have sine squared theta over cosine theta. Okay. Now if I can avoid it, I don't want a fraction. So what I'm going to do next to get rid of the fraction is to go ahead and replace cosine with its reciprocal. So this is one of the cases where we would do that. So next I will have sine squared theta over 1 over secant theta. And then I'm going to multiply by the reciprocal. So sine squared theta times secant theta, and it would technically be over 1, but I'm not going to write that because at this point this would be considered my simplified answer. So I will just basically keep going around in circles trying to simplify. So if you did that, just know if that starts happening, you're going to want to go back to a few steps and then pick what that simplified version is. And again, we're going with this answer over this one because we don't want division if we can avoid it. Okay. All right, next problem. So we have tangent theta times cosecant theta all over secant theta. So I'm going to start by just trying to simplify the numerator. So again, to do that, I'm going to use the quotient identity for tangent. And I want you guys to notice how for tangent, I'm using the quotient identity more often than its reciprocal. And that's going to be true most of the time, okay? So let's see, so tangent we are replacing with sine theta over cosine theta. And at the same time, I'm also going to replace the cosecant with its reciprocal. So 1 over sine theta. And then I'm going to make, again, this fraction bar a little thicker so I remember where that original one was. And then for right now, I'm just going to leave this and work with my numerator. Now, if we want, we could also change it to be its reciprocal right away, so that part doesn't really matter. Okay. Now, in the numerator, I can cross-reduce my signs. So then this will become 1 over cosine theta. And then this would be secant theta. Okay. Now, thinking ahead, there's a couple different ways I can go. I can do the reciprocal to this one, and then we would multiply by the reciprocal of that to get rid of this big fraction bar. Or I could do the reciprocal to this one, which is going to be secant theta. So it's actually going to end up being the same as this one. So secant theta, and then over secant theta. And anytime we divide something by itself, it is always going to be 1. So that will be the final answer to this problem. Okay. I'm going to grab my next sheet here. And now again, at this point, I would pause the video and just do the practice of what you can see. So I'm going to do the next problem. So as you're looking at this one, notice how I have squares in it. So anytime I see that, I want to try to use these Pythagorean identities. Okay? And remember that we are allowed to use the other versions of this. So in the very first video I made of this chapter, I went over that. So I'm allowed to rearrange this. So I could subtract that cosine squared over, and then that would leave me with sine squared equals 1 minus cosine squared. So we are allowed to rearrange and use those. Okay. So when I am looking at problem 12, I have sine squared plus cosine squared. So when I'm looking at that, that is the same as this first one, even though they're not in that same order, because the order that we add things doesn't matter. So I'm going to replace the numerator with 1, because that's what it's equal to. Okay. And then in the denominator, again, I have a 1 and a trig function that's squared. So I should automatically go to those Pythagorean identities. So again, this is where I was talking about how we are allowed to rearrange. So if I have cosine squared theta plus sine squared theta equal to 1, and this is really close to this, except my cosine is with the 1. So I can subtract that over to get sine squared theta equals 1 minus cosine squared theta. So I'm going to replace this 1 minus cosine squared theta, which is here, with what it's equal to, that sine squared theta. Okay. So now I've taken something that looks really complicated and I've simplified it a lot. And now, just to get rid of the fraction, I'm going to use the reciprocal function. So this will be cosecant squared, so I need to keep that same power, theta, for the final answer to this problem.